Poisson and exponential relationship. Poisson and exponential distributions are special parametric families of univariate distributions. Before discussing the relationship of these two distributions, let us recall what is Poisson and exponential distribution. Poisson distribution is a discrete distribution, which means that the random variable is going to take on a fixed integer values. It also deals with the number of occurrences in a fixed period of time. The PDF and the CDF for the Poisson distribution is given by these formulas. F of x sub x is equal to f of x given the parameter lambda sub x is equal to e to the negative lambda, lambda to the x over x factorial, for x is equal to 0, 1, 2, and so on, and 0 if otherwise. And its CDF is equal to f of x equal to the summation of e to the negative lambda, lambda to the I, all over I factorial, where I starts from 0 up to x. The Poisson distribution, mean and variance are all equal to lambda. On the other hand, the exponential distribution is a continuous distribution. When we say continuous distribution, the random variable can take on any value. Exponential distribution deals with the time between occurrences of successive events as time flows by continuously. And here we have the PDF and the CDF for exponential distribution. F of x equal to lambda e to the negative lambda x, where x is greater than or equal to 0, 0 if elsewhere. The CDF is equal to f of x equal to 0, for x is less than 0. And the integral of lambda e to the negative lambda x, derivative of x, evaluated from 0 to x is equal to 1 minus e to the negative lambda x, for x is greater than or equal to 0. The exponential distribution mean is equal to 1 over lambda, and its variance is 1 over lambda squared. Now, exponential distribution has this what we call the memoryless property. Memoryless property means that the expected time until the next event is the same no matter how long since the last event occurred. And here we have the formula for the memoryless property. Probability of x less than or equal to s plus t such that x is greater than s is equal to the probability that x is less than or equal to t. The memoryless property as well as the PDF and the CDF of both the Poisson and exponential distribution are used in identifying the relationship between these two distributions. So, we have these equations. F of x equal to the probability of x equal to x is equal to lambda of t to the x over x factorial, the quantity times e to the negative lambda t, which is the probability function for the Poisson distribution, where lambda is the mean rate of arrivals and t is the period of time. So, by defining t as the time of an event, a random variable, we have by definition, using the memoryless property, we just simply substitute x by t, we come up with this equation. And this is equal to f of t equal to 1 minus the probability of t greater than t. Now, probability of t greater than t is equal to the probability that 0 events occur in time 0 to t. So, we just simply use the Poisson distribution probability function and simply let x be equal to 0. So, this will be equal to lambda t to the 0 over 0 factorial e to the negative lambda t. This is equal to e to the negative lambda t. So, we plug in our result for the probability of t greater than 1 into our equation 3 here, and we come up with this final equation, f of t equal to 1 minus e to the negative lambda t, which is the distribution function for exponential distribution. And that's the relationship between Poisson and exponential distributions.